Hey everyone, welcome back to the channel. Today we are starting an exciting new series about scaling systems, how to take your application from zero to millions of users. In this first video, we are going to cover what scaling means, why it is important, and some of the main challenges you will face as your system grows. Let's jump into it. So, what is scaling? Scaling in system design refers to increasing the capacity of your system to handle more users, more data, or more transactions comparison, without compromising on performance. It's about making sure that your app can grow seamlessly as the number of users grow. Things of scaling like upgrading from a small car to a bus as your passenger count increases. When you start small, a basic setup works, but as your users grow, you need to make changes to accommodate more people. There are two types of scaling: vertical scaling and horizontal scaling. Vertical scaling adding more power to single server. So let's see that we have a client right now here, and it will be white. And this client is sending requests to a server, like a read or write operations, and the server will pull the data from a database. Okay, let's focus on the server right now and the client. When when the client, or let's say that we have multiple clients, and all of them are sending requests to the server, and the server reaches a bottleneck, the server can't handle all of that loads, we need to go with vertical scaling or horizontal or horizontal scaling. We need to scale basically to handle the additional loads that on the server. On vertical scaling, we will add more resources. We add more power to the single server, like increase CPU or RAM. So we add more resources to this server to handle all the other clients. In horizontal scaling, it's quite different. We add more machine, like adding more servers to handle the load. So, and instead of handling one server handling everything, we will have maybe two other servers that could handle the load or that comes from the clients. So this is on high level how vertical scaling and horizontal scaling works. Sorry, I have corona. Okay. Number three, let's talk about why scaling matters. Scaling matters for three reasons. First, performance. Users expect your system to respond quickly, regardless of the number of users. Second, reliability. As the number of users grows, the likelihood of failures increases. Scaling properly helps mitigate these failures. Third, businesses growth. If your app is successful, you will want to grow without limits, and scaling ensure you don't hit a ceiling. So you can imagine you have built an e-commerce website during a normal operation. A single server might be enough, but when your store runs big sale, you could see traffic increases by 10 times. Without scalable system, you risk slow performance or even downtime, leading to lost sales. Okay, let's talk about the challenges of scaling. The first thing that I would like to talk about, which is a performance bottleneck. One of the first challenges you will face in performance bottleneck as the number of requests increases is a CPU, memory, or disk I/O on your server can become overwhelmed. And to fix that, we can go either by horizontal scaling or vertical scaling, depend on the requirements and need. The second challenges is Um, Database scaling. Another common challenge is database scaling. Databases are often the first part of the system to become a bottleneck because they need to manage all the data reads and writes. Imagine a chat application. Every time a user sends a message, the database must store it and retrieve chat histories in real time as the user base grows. This can put a lot of strain on the database. Third, reliability and fault tolerance. Reliability becomes a challenge as more components are added to handle scale. With more server, the risk of failure increases, and you need to ensure that even if one component fails, the system remains operational. For example, if one of your database replicas crashes, your system should automatically switch to another available replica to keep things running smoothly. Okay, let's talk about vertical scaling and horizontal scaling, but let's just give it more detail. As we said before, vertical scaling means adding more power to a single server, like more CPU, more RAM. This approach works well for small scale growth. So if we have, as we said before, if let's say we have a client and we have a server, and the client and server works fine, but let's say that our system it's getting popular, so we have multiple clients right now, and client 1 and client 3, and they are sending a lot of requests to the server, and our server, let's assume our server can only serve one client. So right now we need to scale. So vertical scaling will mean that we add more resources. So basically what we're going to do, we can add more RAM, we can add more CPU to have a bigger server that can handle all this load. Okay. The advantages of vertical scaling is that it is quite simple. You just upgrade your existing server, but it has limits. You can only upgrade a single machine so much before you hit the hardware ceiling, because there is a physical limit for that. Let's just delete all of that and let's talk. Yeah. Okay. Let's talk about horizontal scaling for now. Horizontal scaling means adding more servers to distribute the load. This is a preferred approach for systems aiming to handle millions of users. So let's say that we have client 1 and client 2 and client 3. So instead of having one big server handle everything, we will have multiple servers, server 1 and server 2 and server 3, that handle all the loads that are coming from the clients. The advantage of horizontal scaling is that it's more scalable. There is no theoretical limit. You can keep adding more servers as your users base grows. But it's more complex, requiring techniques like load balancing and data partitioning to ensure smooth operation. And I will talk about load balancing and data partitioning in details in future videos. So let's make an overview of the scaling strategy. Strategies. Okay. So there are things that we will talk about. First, load balancing. It's to distribute traffic across multiple servers. If you look at this one, we need to know how client 2 knows which server it will connect to.